You know that feeling when you're cruising along at 2000 RPM in sixth gear, thinking you're being gentle with your engine? That smooth, quiet ride where everything feels efficient and controlled? You're killing your bike. I am serious. That low RPM riding everyone says saves your engine is causing catastrophic damage right now. Carbon deposits are choking your combustion chamber. Metal stress leads to detonation. And your traction control system is sitting there useless because you're not giving it enough RPM to actually save your ass. I am breaking down 3 ways lugging your engine costs you thousands in repairs. I guarantee you are doing at least one of these right now. Here's what actually happens inside your engine when you baby it at low RPM. Carbon starts forming deposits at 200 degrees Celsius. That is basic combustion chemistry. But here's the kicker. That same carbon breaks apart at 325 degrees Celsius. The problem is, you are never hitting 325 degrees Celsius when you are putting around at 2000 RPM. There is not enough heat and not enough airflow, so those carbon deposits just sit there, building up, eating away at your compression ratio. Eventually, they get thick enough to cause real problems. The Italian tune-up is not an old wives' tale. It is thermal chemistry. You run the engine hard, you hit those higher temperatures, and suddenly you get enough airflow blowing through to carry that broken down carbon right out your exhaust. I have seen this firsthand. Barn-find bikes that sat for years were running like garbage. Then you take them out, run them hard for 20 minutes, and they make power they have not seen in a decade. One piston ridden hard stays clean. One piston ridden soft gets choked with deposits. But that is just anecdotal evidence, right? Look at the actual metal. High RPM pistons come out cleaner. Low RPM pistons look like someone painted them with tar. The financial reality here is brutal. Carbon cleaning service runs you $400 to $800 depending on the shop. That is money you are throwing away because you thought you were being gentle with your engine. Prevention costs nothing. Just use the RPM range your bike was designed for. But carbon buildup is just the start of the problem. Here's the physics that destroys engines. Your combustion chamber releases the same amount of energy every single time it fires. That is fixed. What changes is how fast your piston is moving when that energy hits. At high engine revolutions per minute, the pressure has somewhere to go. The piston is already moving down fast, so the force is distributed across the entire stroke. At low engine revolutions per minute, you have massive cylinder pressure and nowhere for it to escape. The piston is barely moving. All that force concentrates into fewer, harder hits on the metal. Think about pushing bicycle pedals up a hill. High gear with low cadence, you are grinding hard, standing on the pedals with your full weight. Your knees hurt. Low gear with high cadence, you are spinning easy, and each stroke requires way less force. The hill speed can be the same, but the stress on your joints is completely different. Your engine works exactly the same way. Low engine revolutions per minute means extreme pressure per stroke because the piston is not moving fast enough to distribute the load. That creates localized hotspots in the cylinder. Those slow rotations also mean you are spending far more time in the dangerous detonation zone. Here's where it gets catastrophic. On modern 4-stroke street bikes under load, one abnormal combustion event while the piston is still rising can cause detonation. The piston is trying to go up, and the combustion pressure is forcing it down. Something has to give. Bikes do not experience this exactly like turbocharged cars, but the underlying physics do not care what badge is on the tank. Studies on metal fatigue prove this. Pressure spikes cause more damage than cycle count. Your engine would rather spin 10,000 times with moderate pressure than 2,500 times with extreme pressure. The math is clear. I have watched mechanics pull apart engines that grenaded from detonation under load. The damage is unmistakable. Piston crowns with holes punched through them. Cylinder walls scored beyond repair. Connecting rods bent like someone took a hammer to them. The worst part is this damage happens gradually. You do not get instant catastrophic failure. You get micro damage that accumulates over thousands of miles of low engine revolutions per minute riding. Your compression drops slowly and your oil consumption creeps up. Then, one day you are accelerating hard from low revolutions per minute and the whole thing lets go. But riders do not see it that way. They look at the tachometer and think, 7,000 revolutions per minute sounds abusive. It feels wrong. Meanwhile, 2,000 revolutions per minute feels smooth, controlled, and responsible. You paid for the whole tachometer. Your manufacturer put that red line at 10,000 revolutions per minute for a reason. They did not set it as a suggestion or a maximum emergency limit. They set it because that is the healthy operating range for your engine. It is a catch-22. High revolutions per minute wear your odometer faster because you are doing more revolutions per mile. But low revolutions per minute destroy the actual metal with pressure damage. Between those two evils, low revolutions per minute is the greater danger every single time. And it gets worse when you factor in modern safety systems. Your traction control works by cutting power pulses. The computer monitors your wheel speed against your crankshaft speed. When it detects the rear wheel spinning faster than it should, it cuts individual combustion events until the crankshaft syncs back up with the bike's rate of travel. The math here is brutal. At 2,000 revolutions per minute in 6th gear, the computer gets 33 opportunities per second to correct your mistakes. At 8,000 revolutions per minute in 3rd gear, you are giving it 133 opportunities per second. That is 4 times faster response and 4 times more chances to catch a slide before it becomes a crash. Think about hitting a patch of gravel mid-corner. Your rear wheel breaks loose. At high revolutions per minute, the traction control fires almost instantly. Multiple corrections happen before you even register the slide. The bike stays composed and you ride through it. At low revolutions per minute, that same slide happens and the computer is sitting there waiting for the next combustion event. By the time it cuts power, you are already sideways. The correction comes too late. You are fighting to save it instead of the bike saving you. Modern bikes are designed for this. The engineers built these systems expecting you to operate in the meat of the power band. They tuned the algorithms around 6,000 to 9,000 revolutions per minute because that is where the bike lives. You are fighting the engineering when you lug around at 2,000 revolutions per minute. The safety trade-off is insane. You may think you are being smooth and controlled, but you are actually compromising the systems that prevent crashes. Your ABS works better at higher revolutions per minute. Your traction control works better at higher revolutions per minute. Your engine braking works better at higher revolutions per minute. I have seen crashes that should not have happened because the traction control could not react fast enough. The rider was in 6th gear at low revolutions per minute, hit a wet patch, and the bike stepped out. The computer tried to save it, but there were not enough power pulses to work with. Same corner, same conditions, higher revolutions per minute in a lower gear, the bike catches the slide automatically. The rider does not even know they were in danger. The worst part is riders feel safer at low revolutions per minute. It is quieter, it is smoother, there is less vibration. So they convince themselves this is the responsible way to ride. Meanwhile, they are disabling the safety systems they paid thousands of dollars for. Your bike is smarter than you think, but only if you let it work the way it was designed to work. Here is the mental block that stops riders from using proper revolutions per minute. High revolutions per minute add miles to your odometer faster. You are doing more revolutions per mile traveled. That feels wasteful. It feels like you are wearing out the engine, but this is the exact same force concentration issue we covered earlier. Those extra revolutions distribute wear evenly. Your bearings see consistent loads. Your cylinder walls get proper lubrication. Your piston rings seal correctly. Everything works the way it was designed to work. Low revolutions per minute concentrate all that wear into pressure damage instead of cycle damage. A bearing that can handle 1 million smooth cycles will fail at 200,000 cycles if you keep hitting it with pressure spikes. Manufacturers know this. That is why they validate engines at high revolutions per minute during durability testing. They do not run test engines at 2,000 revolutions per minute for 100,000 miles. They run them at 7,000 revolutions per minute because that is the operating range that proves reliability. Track day bikes run all day at high revolutions per minute without issues. Racing engines see sustained high revolutions per minute for hours and come back for more. Street riders baby their engines to death by lugging them around at low revolutions per minute. Then, wonder why they need rebuilds at 30,000 miles. 7,000 revolutions per minute feels abusive. It sounds loud. It feels like you're thrashing the engine. But that is the healthy operating range. That is where your oil pressure is correct. That's where your cooling system works properly. That's where all your tolerances line up. You paid for the whole tachometer. Use it. Modern engines are built with higher redlines for a reason. Your manufacturer did not slap a 10,000 revolutions per minute redline on your tachometer as decoration. They did it because that is where the engine is designed to operate. Look at how they validate durability. Engine testing does not happen at 2,000 revolutions per minute. They run test motors at 7,000 to 9,000 revolutions per minute for hundreds of hours straight. They heat cycle them, they load them, they push them through the entire operating range repeatedly. That is how they prove the engine will survive. If low revolutions per minute were healthier, they would test there. They do not. The two-stroke riders learned this lesson decades ago. Run a two-stroke at low revolutions per minute and you get oil fouling on the spark plug. The engine loads up, runs poorly, and eventually dies. Get it up on the pipe where it is designed to run, and suddenly everything cleans up. The engine screams, the power comes back. That is not abuse. That is proper operation. Four-stroke engines can lug around at low revolutions per minute because they have more torque and better lubrication systems. But just because they can does not mean they should. It is a capability, not a recommendation. Your bike can also do a burnout until the tire explodes, but that does not make it a good maintenance practice. Here is the track reality check. Track day bikes run at high revolutions per minute all day long. 8 hours of sustained high RPM operation with maybe a dozen cool-down laps. Those engines come back for more. They do not grenade. They do not need rebuilds every weekend. They just work. Meanwhile, street riders are babying their engines to death, cruising at 2,000 revolutions per minute because it feels responsible, never seeing the top half of the tachometer because that seems like abuse. Then, they need valve jobs at 25,000 miles and wonder what went wrong. The warranty reality should tell you everything. Premature engine failure from carbon buildup, or LSPI, is not covered. The manufacturer knows you caused it by operating outside the design parameters. They built the engine to spin. You chose to lug it. That is on you. The mental block is the hardest part to overcome. You have been conditioned to think high revolutions per minute equals abuse. Every time you see 7,000 revolutions per minute on the tachometer, your brain screams that something is wrong. It sounds loud. It feels aggressive. It seems irresponsible. But that is the healthy operating range. That is where your oil pressure peaks. That is where your cooling system flows properly. That is where your fuel injection maps are optimized. That is where every tolerance and clearance lines up exactly how the engineers intended. Your bike is telling you where it wants to operate. Listen to it. So there are your three killers. Carbon deposits choking your combustion chamber because you never hit cleaning temperatures. Detonation under load destroying metal with pressure spikes your engine was never designed to handle. And safety systems are dramatically less effective because you are not giving them enough RPM to actually work. The financial reality is brutal. Carbon cleaning runs $400 to $800. Detonation damage starts at $3,000 and goes up from there. Prevention costs nothing. Just use the RPM range your bike was built for. Which of these mistakes have you been making? Drop a comment and tell me your typical cruising RPM. I want to know how many of you are out there lugging your engines to death right now. And hit subscribe so we can keep building a safer, smarter riding community together.